Advanced Concepts Presentation Number 7 by Amanda Flores. Instructions. We were asked to explain the cholesterol biosynthesis, research lovastatin, also explain how lovastatin inhibits cholesterol, and also share if the structure of lovastatin changes when it becomes active through the use of pictures and graphs. So what is lovastatin? Lovastatin is also known as Mevacor, and it's made by Merck Pharmaceuticals. It's used to treat high cholesterol as well as it can also reduce the risks of heart attack, stroke, and blood vessels. And here you can see the structure of lovastatin. So for this next slide, it's to help explain the cholesterol biosynthesis from acetyl-CoA all the way to cholesterol. So we start off with the HMG-CoA formation. So with acetyl-CoA to acetyl-CoA, you go to HMG-CoA with HO2 going to CoA exiting. So then we go to HMG-2-melavanate through the use of the enzyme HMG-CoA reductase. 2-NADPH is transformed to 2-NADP+, and melavanate becomes isopentenyl pyrophosphate, which is also known as IPP. 3-ATP becomes 3-ADP. PI and CO2 are also thrown out of this pathway. So then we go to phosphorylation within the pathway. So isopentenyl pyrophosphate IPP goes to farnesyl pyrophosphate FPP. We add 2-IPP, which then releases 2-PPI. So from farnesyl pyrophosphate to squalene, the reaction begins to condense, and NADPH releases NADP+, and FPP releases 2-PPI. So now towards the end, where cholesterol is formed, we go from squalene to cholesterol, and NADP+ is added, so is O2, and NADP+ is released along with H2O. And once cholesterol is formed, there are 3 different routes it takes, which are stated right here, and it says it goes to bile acids/salts, steroid hormones, or vitamin D. So how does lovastatin inhibit high cholesterol? Well, lovastatin obviously reduces the high cholesterol because it acts by inhibiting the enzyme 3-hydroxy-3-methylglutarol, coenzyme A reductase, which is involved within the biosynthesis of cholesterol, and that is how it lowers high cholesterol and prevents or reduces the risks of the other potential risks you can be at, such as heart attack and stroke. So here we have the if a structural change of lovastatin happens between active and inactive, and yes, it does. So when it's inactive, you see on the left hand side it's like all perfectly put together, and you can see on the active, once it becomes active, the right hexene type structure is opened up, which allows it to be active. And that is all. Thank you.